For those of you who always wondered what was inside a color laser printer, well, wonder no more, because we're going to take apart two of them in this video. One's going back together because it's still functional. The other one, well, it's shot, so it's coming apart completely. And we're going to take everything apart on it, including the optical scanner, so you guys can see what's inside it before I send that one off to recycling. So let's get started. We're going to start out with the Samsung CLP 510, which I've had for 18 years. And say this one's functional, but it's not printing very good. So I want to see if I can get this thing clean and see what's going on inside here. See if I can improve the quality on this one. I mean, I can't get parts for this anymore. So it's like, I'm not going to put a lot of effort in, but I want to see if I can improve the quality of the print. So if you remember before, we took this apart and I cleaned out the excess toner that was backing up in it. And got most of it out. I don't think I got it all out, but I got most of it out. It's certainly by the end of this little procedure, it's going to be working a lot better than it was. And I'm just kind of presenting this more as almost a live presentation. We're not going to do a lot of editing on here because, especially with the next one that's coming up next, because it's going to be a total teardown. We're going to rip everything apart on an HP Laserjet 1600. After, of course, I determined that it wasn't going to be viable to repair it. And I did take it to a shop because, well, you'll see. One of the cartridges itself was done. Like, it won't print. It wouldn't turn on. So rather than spend 80 bucks and buy a cartridge only to find out that the unit was shot, I took the printer into a shop and they put a new cartridge in so we could run some diagnostics and see whether it was more than the cartridge. And a whole bunch of error codes came up, and the guy just laughed and he said to me, well, I'll talk about this a little later, but he told me if you had $1 for every time someone gave someone a printer and said, oh, all it needs is a cartridge, he said he'd be rich. So that was the story on that. Was I was given it, I was told all it needed was a cartridge, but it needs a lot more than that. So that one's going to be taken apart fully, and we're going to rip it apart.
The laser shines up through the slot. I'm just cleaning the mirrors and so forth down in here.
So this one here, actually, the laser is, as we're going to find out, I got to remove a cover, but the laser in this unit is actually completely sealed, which I was quite surprised. It's got a glass cover over it, and it actually has a broom that sweeps that off every time you open it up. You can't see it now because the cover is closed, but if I close the lid on the left, it actually opens up this
tabs that hold this in place.
Aperture, which we'll see that once I get the cover out, which I'm in the process of doing now. 2 screws and a couple of clips, and the cover pops off, and then the laser assembly is under there, which I'm not going to take apart on this one because obviously this printer is still in pretty good shape and it works quite well. Considering the age, it actually works really well.
Should lift that out now. This is the cover for the laser.
You can see the brush, the shadow from the brush in the light there. And when I close the door, see, I found, oh, there's a brush in here. What's this? This is the cover that covers up the laser, and you can see it move.
Oh, there's a brush that, when you open this up, there's actually a brush in the back. Interesting, I didn't see that before, but there's a brush that's controlled by opening the door, which actually cleans off the lens. Right down there. I don't know if you can see it or not. See if I can get the camera in a little closer. This is actually a brush, and as you close the door, it opens up the optics for the laser, which is sealed, which is actually a good design. It keeps dust and stuff out. Every time you open the door to change the toner cartridges, the brush slides over top and cleans the optics. Cool, huh? So here's the cover plate back in place with the laser cover. You'll see the opening down here. This is where the flashlight is shining. That's where the laser is located, and it's not actually exposed until you close the toner cover. It has a brush in there that brushes that off to keep any dust and dirt out when you've got the machine open. I'm going to reinstall the drum and the transfer belt, and we'll run a few test pages through it. So the drum back in. And I print a demo page. See how the demo page prints now that I've put it all back together after cleaning it up a bit inside. Still got to clean the exterior to it here, but it's going to print on both sides. We'll do another one here, see if it will improve. Demo, information, menu map, demo page, demo page. See if it will clear this up a bit now that it's run a few times. The drum itself is probably on its last legs, as is the transfer belt. We'll see.
You can hear the transfer belt thump, thump, thump as it prints the 4 colors. In monochrome mode, it just spits paper out like 26 pages per minute. But in color mode, it's only like 6 because it has to do it 4 times.
Oh yes, we'll do another couple of pages and see if that'll clean it up. Seems to be improving. So I've printed a few pages on it here. It's getting better with every page. This will be the 5th demo page that I'm printing, which is printing on both sides, so that's like 10 sheets. As you can see, it's certainly, my cyan toner is low apparently, but it's certainly better than the first page that came out of here. Still not as good as it was when it was new, but I mean it's, you know, it's 18 years old, so I guess it really doesn't owe me anything. Looks like there might be a scratch on the drum. Got the vertical line on it, but I guess for a printer of this vintage, it's probably not doing that bad. Actually, it doesn't look too bad at all. It's obviously showing its age. I don't want to sink any money into this thing, obviously, because I don't even know whether the toners are available anymore for it. It's pretty old, but I figured I would give you guys a second kind of look at this thing to see how it was looking. Certainly looking a lot better than when I started. It might get even better if I were to print something on it. Run a few more pages through it. It might get a little better, but oh well. It's, again, a very old printer, so it doesn't owe me anything. Which is kind of just a fun thing to do to see if I could improve this old beast. But likely it's just going to end up going to recycling because it's not worth anything. It weighs a ton. And again, the consumables on here are to the point where you can't even refill the cartridges easy because, like, it's got page counters for everything. So the drum's got a page counter, the fuser's got a page counter, the transfer belt has a page counter, the cartridges all have a page counter. And once you get to that limit, it just won't print anymore. It just says, like, it says that the toner, cyan toner, is low. And that typically means I'm down to a couple hundred pages, and then it's going to come up and say cyan toner is empty. Whether it's empty or not, it could be completely full, but once the page counter hits that point, it just won't print anymore. And at one point I bought a new set of cartridges. I think they've all gone into it by now. It used to be a shop, I think it was called, was it Office Depot? The one that went bankrupt. Anyway, it was probably 10 years ago or more, maybe 15 years ago. I think it was Office Depot, whichever one went bankrupt. When they shut down, they put everything on 50% off, and I bought a new set of toner cartridges for, I think the regular were like $100 a piece, and they had them on for like 50 or 40 or whatever half price was. And I bought a new set of cartridges for it. But they've all gone through the printer. They're all in there now. I've got the empty ones sitting in boxes that I thought maybe I might be able to get refilled, but I haven't been able to find. I go to these places that refill cartridges. Can you refill the cartridges on my Samsung? Oh yeah, we can refill them, but we can't reset the chips. Wonderful. So, planned obsolescence, as they say, right? Great old printer. As I say, this thing doesn't owe me anything. It hasn't had a lot of pages through it like an office printer would, but for me it's done the job. So maybe it's time to move on, because I do have other printers that people have just given me. And I do have another color laser sitting in the house. I haven't even tried it yet to see how it works. So this is my other free printer. This one's a little HP color printer. I haven't used this thing since I got it. From what I understand, it works, but I haven't put it in service. It was sitting in my spare room that my son's been using for his games and crap. It says replace black cartridge. This one here has the cartridges in here. Dust in it. Probably got everything else falling in it too. My bonehead son was using this as a place to put his feet up and put drinks and stuff on. These ones all have their own drum for each one. So each color's got its own. So when you buy a new cartridge, you get a new drum. That's the HP expensive way of doing things. And that's one of the reasons I never put it into service, because I think it needs a black cartridge. I don't know if it needs anything else. I'm hoping I can fire this thing up and actually make it print something. Looks like I got to blow the dirt out of this thing too. All the dust bunnies and crap that's been in here from the couple of years it's been sitting in the storage. It's not really a storage room, it's my family room that my son took over as his game room. Probably won't do anything because it's going to be low on black. I wonder if I can force it to print a test page. That'd be nice if I can make it print a test page. And we're at the same dilemma. This unit has a chip in it. It also has optical sensors on it that detect if the toner is actually empty. But there's a little optical sensor here. It shines a light through so that it can see if there's any toner in it. But of course there's a chip, and it counts the pages. And there's the problem is, you know, once they get to that page count, you got to buy a new cartridge. At least with this one, you're getting a new drum as well with it, but these cartridges are not exactly cheap. So that's when I have to decide, do I want to invest in a new cartridge to see if the printer works, if there's another problem with it. I mean, look at all the crap that's on the transfer belt, although it hasn't had a page go through to clear it off yet. So but there's a good chance that there's more than wrong with it than this. The other cartridges probably are also in bad shape. And you can see the drum where there's been toner on it. Now running in the cleaning mode might fix that. It might clear that all off, just because I haven't been able to get a page to go through it because of the black being empty. Lots of dust in this thing from just sitting around. When it was given to me, I was told that it worked. It just needed a cartridge. But again, I've been sitting on this thing for a couple of years, kind of hanging on to it for when the Samsung finally bit the dust. What I'll do is I'll check out one of the local places that refills cartridges and see whether they can refill this one and reset it. And we'll go from there and see how this thing looks. Might be one worth keeping. It's in pretty good shape. I think it's not a duplex printer. It doesn't print both sides, but it's a lot smaller than the Samsung. But if the print quality of it is good enough, I'll hang on to this thing. So I guess that's the next step, is to get a new black cartridge. So on the printer here, I took it into one of the places that sells cartridges, Reman cartridges and so forth, because I didn't want to spend, well, Reman cartridge is 80 bucks. So I didn't want to spend 80 bucks on this to find out that there's other problems. So I was talking to the guys there, I just bring the printer in, we'll throw a new cartridge in it and run a test page through it and see if it works. So they threw a cartridge in, fired it up, and it made the most horrendous noise. Sounds like bearings are failing in the scanner. That's what it sounded like. Just made a screeching sound, and a whole bunch of error codes came up on the screen, which of course won't show up now because it's got the dead cartridge in it. It won't do anything. So the guys just said, you know what, throw it out. And he tells me the story. He says, you know, he said, if I had $1 for every time someone comes in with a printer and says, yeah, I got this printer given to me and I was told all it needs is a cartridge. He says, once in a while that's true, but he says 9 times out of 10 it's something a lot more serious than that. So this printer is not going to be repaired. This printer is going to be a teardown. Like, I mean, he shows me, he says, look, he says all the cartridges are bad. When it started up, it didn't even print a test page. It just put toner all over the transfer belt. But he was telling me that, you know, he says this is an indication that all the cartridges are bad. He says, you know, this one here, that one's bad. And he says, you know, it's going to need all the cartridges replaced, plus God only knows what else is wrong with it. So what's going to happen on this is you guys are going to get to see this thing taken apart, because I'm going to tear this down and then recycle it. We're going to open it up. We'll open up the laser unit, open up the everything. So it's going to get messy. So I'll pull the cartridges out, and we're going to start ripping this thing apart. On this one, if you look on this one, I don't know, it's got a single laser, it's got 4, but here are the windows at the back here where the laser actually shines into the cartridge. Throw some light in there. See, the chips get red here, but there's also optical sensors on either side on these funky cartridges. So in the cartridge itself, there's a little window. So the printer knows if it's got ink in it, or it's got toner on my hand. There's one on the back here, and there's one on the bottom. And it shines the light in, and it's able to detect if the light, I guess, is able to shine through. The light goes in one and shines out the other. It knows it's empty. But it also has the chip that counts the number of prints that's been done, and once it gets to X number of prints, this is just a memory chip that's in here. Once it gets to X number of prints, it says, okay, I'm done. Time for a new one. And that's what they do. And there are ways to refill the cartridges. You can I guess one of these is the reservoir tank, and the other one is the supply tank. There's 2 tanks on here. One is where the toner goes in, and the other one is where the toner gets recovered when it's scraped off things. This is the tank here that shows that, you know, the toner gets picked up in there. Anyway, the laser shines down. You can see the green drum in there. The laser shines in through there as it's spinning and scans the print. Scans it to make the print. And also inside here there'll also be a chrono wire in here as well, I'm sure. It's got to be, because they have to charge the drum, right? They put a high voltage on what's called a chrono wire that put a static charge on the drum, and then the laser hit the photosensitive surface on the front. Where is this thing open? The laser hits the photosensitive surface. It discharges the pre-charge that's been put on the drum, and then the toner sticks to wherever the charge remains, and then it transfers over to the transfer belt. And again, it's done electrostatically. Electrostatic charge pulls the toner from one surface to the other, and then it's pressed onto the paper. That's how they work. Anyway, we're going to take these things apart and see what's inside it. So this is what's called the transfer belt. On this particular printer, how it works is when it's closed, the transfer belt is spinning, it spins that direction, so it's going down. So as it passes over the black, yellow, cyan, and magenta in that order, the rollers or the drum presses up against the transfer belt and transfers the toner from the drum to the transfer belt. As the transfer belt continues on its way, the paper is drawn up through the back and pressed up against the back side of the belt as the belt comes up. The toner is then transferred to the paper, and then up into the top is the fuser, which is a hot roller which fuses the toner to the page. That in a nutshell is how laser printers work. Actually quite simple when you think about it, kind of like a photocopier. Photocopiers work pretty much the same way. You had a photosensitive drum, you charged it with an electrostatic field, and wherever there was white from the paper reflecting back, the paper being copied was passed over some mirrors, and a very thin slice of the image as the copier moved back and forth was reflected down onto the drum, which was synchronized with the, I'm talking the photocopiers that went back and forth, right? They did it after that with moving mirrors, where the paper itself was stationary, or they dragged the paper through over a stationary optical pickup. But the image from the paper, wherever white was present, would hit the photosensitive drum and discharge the static charge that was placed onto the surface from the corona wire. Then the toner was brought close to the drum, and anywhere where light did not hit, in other words black portions from the page that was being copied, would stick to the drum, and then it would be pressed up against the toner, against the copy paper. It would transfer to the copy paper, and then a fuser would fuse it. Laser printers work the same way. The laser beam turns on and it discharges the drum as it's scanning. And it's scanning by means of a mirror that is spinning, a multi-sided mirror, so that the laser beam is scanning one side to the other. And they turn the laser off wherever you want toner to remain, and you turn the laser on where you don't want toner. Then when it passes over the toner reservoir, toner gets picked up, transferred to the page. Black printers just have a single cartridge, color have 4. This one does all 4 at the same time. The Samsung that you saw at the beginning of this video, it uses a large drum, and it uses a different transfer belt, and it does it in 4 passes. So if you're printing just black on the Samsung, it's very fast. It prints like 26 pages per minute, because it just operates just the one cartridge, and just one page at a time. But if you're printing 4 colors, then it has to actually go over it 4 times. So it does the black, and then it does the yellow, and then it does the cyan, and then the magenta, and then it picks up the paper and deposits all 4 of them on the page at the same time and builds up your color print. That's the difference between the two of them. This is a much lighter machine. The other machine weighs like 80 pounds. This one here only weighs about 20. Anyway, let's get on with the disassembly of this machine. I've never taken one of these apart, so this is going to be a learning experience for me too. And then off to recycling it goes. So I wonder what happens if I take out these screws. I guess we'll find out. We'll see what was making that horrendous noise. Now I got to just decide what I want for a color printer. I mean, I've still got the Samsung, but the problem with the Samsung is the parts. Like it's virtually impossible to get the parts for it. Nothing's available. You can't even buy the toner cartridges anymore, apparently, so I'm told. The guy at the printer place told me that that one is just too old. They just don't have any parts for it. I'm just waiting for a guy to come over and pick up a TV. Fixed it, a little old LG set there. A few months ago was given to me, like a 37-inch, and I replaced capacitors in it. I've had the thing up for sale. I started out at 50 bucks. Nope, Nobody wants a 37-inch LCD set for 50 bucks. Then I went to 40 bucks. Then I went to 30 bucks. Then I went to 20 bucks. I get a call from a guy saying, I'd like the remote for it. So I sold him the remote for 10 bucks. I put the TV up for $10. Well, what it cost me in parts, I replaced all the caps in the power supply. So I got 10 bucks for a 37-inch TV. In good shape. So I'm just waiting for the guy to show up and pick it up, take it off my hands, get some more crap out of here. Oh look, it's got boards with craps on it. That'll be the next thing, you know. Could imagine if the printer had worked and I bought the cartridge for it and then got home and found out that it didn't print because the caps were bad on the USB interface board. It would always have been a possibility, but no fear, it's coming apart. Oh, the Tesla just pulled into my driveway to pick up a TV. So next we'll pull the interface out. Yeah, got 10 bucks. 10 bucks for a 37-inch TV. It's nice to get rid of it. I'm tripping over this stuff. This was a set that was given to me, right? And I put caps in the power supply, rebuilt it. So at least I got my money out of the parts. Didn't make anything on the set. Make money from you guys watching me fix it, and that was it.
Fixed it back in January. I think I made about 50 or 60 bucks on the video so far, so I guess I did okay on that one.
Guy shows up in his wrapped Tesla. See a lot of those around here.
Lots and lots of Teslas and electric cars. I think we have probably one of the highest adoption of electric cars in the country.
I guess that's what you do with your Tesla when you don't like the factory colors that are available. Yeah, wrap it. Okay, what else has got to come off on this? This bracket's got to come off. We're going to take this whole unit down to like bare bones. So bear with me. This could be a while. We could be watching this one for a while today. Oh, all that work and that was just a bracket. Something else has got to come down here. It looks like this folds down. It looks like this is on a hinge of some type. Does that fold down from here? I guess I'll find out. We'll be saying that a lot on this one. I've never taken one of these printers apart before. I am not a printer technician. I never have been. So this is kind of a learning experience for me as well, as to the procedure to open this thing up. But it doesn't need to go back together, so whatever has to come apart on this thing comes apart. What is that? Is that a buzzer? What's that little part? HSU07. Have no idea what that is, but something. And there's a screw up here. We'll just start removing screws and see what falls apart. I would imagine if I take the top off, I'll get the I get the fuser and everything out on the top, but the side panels should come off of this, I would think. Okay, that side should pop off. That's the power supply. A couple of screws on the side, and the side panel should pop off, I think. High voltage board. Okay, that's one side off. Let's get the other side. Is this for the? This might be for the corona wires right here. For something. What is it for? Yeah, I bet you that's the corona wires. We look, they make a contact right here. So there'll be wires that go in behind here that is used to provide a high voltage charge that will pull the toner from the drum onto the belt. Another screw on this side to remove this side cover. You see, then when I take this to recycling, I kind of have to stick it somewhat together. I don't think they would appreciate me if I walked in with the printer in pieces. So here's a bunch of parts. You can have this to recycle. I think they're going to probably want me to put it reasonably together. Oh, another one over here. There, now this side cover comes up, and this is the gears and motors and crap that drive it. So on this side we've got a solenoid to release the paper. That operates the paper roller. When that kicks in, it would then drive the paper rollers. And these gears here on this side and this motor, this is what's going to operate the drum pack. It's a little fan over here. Say something when it spooled up made one heck of a loud racket. It sounded like it was possibly the scanner firing up for the actual laser itself, which is still buried inside. This is the laser pack back here. Now if I undo a couple more screws, I should be able to remove all that effort for that. This has got to come out somehow. Turn it over, I guess, the other side. When they say high voltage, they mean it, because the voltage that gets derived and sent up to the corona wires is in the thousands of volts. It's, 1,000 volts that get sent up there. It's quite high. Don't quote me on that, but I know it's high. This is where it comes out here, right? This is a high voltage side. There's a transformer in here, like a flyback transformer on a TV, and that generates the corona voltage that is used to attract the toner electrostatically. This top piece should lift off too, somehow. Maybe it's these screws here. Okay, that comes off. And then 4 screws should lift off the fuser assembly. This is the fuser here. Or at least lift off the cover for the fuser. Okay, there's the top cover with the control panel. Here's the fuser assembly. What do you think the chances of this going back together are? I would say slim to none. Fuser rollers here. This is the fuser motor that operates the rollers here for the fuser. You can see the top of the belt right there where the paper comes up. Paper comes up through here and goes through here. just seeing what screws have to come out to remove this. I guess there's one more back here, a couple of them on the back here, and then this unit should unplug. Certainly not modular like the Samsung that I took apart. I mean, I didn't tear it all the way down because it's still a functional printer. And I'll still probably use it for a bit. My other printer is a inkjet printer, but it's I haven't used it in a few years, and the 8 ink cartridges have all dried up. Go figure. So the cost of replacing the ink cartridges is warning to unplug the power. Really? You think? You're going to tear it down this far with it still energized? I don't think so. Anyway, my other one, say 8 ink cartridges, and the ink cartridges themselves are all dry. So it's I'm at that point. So to buy the 8 ink cartridges, probably a printer would be cheaper. I don't know what they cost. They didn't used to be that expensive, but I don't know what they cost these days for the BCI 6 Canon cartridges. They are probably getting hard to source as well, like everything else. Like everything is these days is getting hard to get parts. You got computer equipment that's more than a couple of years old, and it's just impossible to get parts for them. But I mean, even these colored lasers are not that expensive, not like they used to be. That screw is marked with an arrow, so I think that one needs to come out. This is a jam sensor, this one. So when the page comes through, this lifts up, there'll be an optical sensor on here that detects when this is lifted, and then when the page finishes, that drops. That's how the system knows that the page didn't jam. Okay, that's the fuser. That should lift out. Unplug it. Unplug it here or there and everywhere, wherever it plugs in. These wires are not part of it. These are going somewhere else. That lifts out like that. This is the heater wire. There's these big wires here. This is mains voltage that heat up the heater in here. So it'll be a quartz lamp, like a light bulb, a quartz heater that gets up to, I don't know, probably about 150 degrees Celsius, somewhere in there. Don't know what the specs is on this, but it gets pretty warm. And its job is to fuse the toner to the paper. And that's why jam sensors are so important, because if you have a jam and the paper gets jammed where it's hot, you want to make sure that you cut off power to that heater real quick. Otherwise, you could have an ignition source, and photocopiers and laser printers have been known to cause fires. But there's, oh, look at the fuser. Holy crap. Look at this. It's got fused toner on it. If I put power to this thing, this thing will heat up. It's got a lamp in it that goes through here. There'll probably be a limit switch on here as well, I'm sure. But if I were to put 120 volt, because it's going to run on mains for sure. If I put 120 volts across here, this thing would get hot. And as you can see, the paper goes in between here, the side with the toner down. But as you can see, when this thing failed, there's been toner everywhere. Toner all over there. So this is probably shot too. And again, another reason why this printer is not being fixed, because this fuser itself is shot. Like everything else on this printer, it's going to be shot. Next, we'll pull the power supply board, wherever it comes out. Seems to be held in place by something. besides wires. Got the screws out on this side. Oh, there's another screw down here. A buddy of mine calls me this morning all excited. He says, "Are you going to watch Survivor?" I said, "No, I'm not. Why?" He says, "Oh," he says, "my daughter's boyfriend is appearing in it. He's premiering tonight." My answer to that was, "So?" I said to him, "If it was my daughter's boyfriend appearing in Survivor, I wouldn't watch it." But for those of you that do, he's the Canadian. I'll leave it at that. You can figure out who it is. Because there's only one Canadian on the show this year. Okay, let's get that taken out. Oops, those pieces are breaking. Not to worry. It's not going back together. I'll probably hang on to this board, the power supply board, just for, because it may have some parts that I could use, like big filter caps and stuff, right? So I might just hang on to this piece, just because I know that there may be parts in here that I could use. And the recycling place is never going to know that it's had parts pilfered from it when it does go in to be dismantled by whoever. I want to get the laser out there. I want to see what the laser looks like on this. It's like, come on. Okay, that's that one out. And of course it's got, like here, they tie down one wire but not the other. There we go. Alright, now that's got that sort of free. Another plug back here. Okay, power supply is out of the way. I guess next is this big plate here. Lots of screws, that's for sure, from this. Lots of leftover screws. Okay, this piece should lift out now. There's maybe other screws behind here that I haven't got yet. And all the different sensors. Just like that. It's just that easy, folks. It's just that easy. Nothing like color coding your wires, right? Making them all purple. Is that an HP thing? Is that their color? HP's color purple? Okay, what's holding this in place? More screws in the back here, and this back panel should lift, and then I should be able to get into where the optics are on here. Still got a lot of tearing down to do on this. Glad you guys are sticking with me. You're probably hitting the fast forward button as you're going, right? It's funny, you know, I went to check out my video that I just posted, and the ad that popped up on my screen must be dragging the bottom of the barrel here, was an ad for cannabis. For those of you in countries where that's illegal still, it's legal here, and the sellers are buying time on YouTube. thought that was kind of funny. Now what's even funnier though is why they would target me with that ad. Because it's not like I'm a consumer of the product. Jeez, this thing's got a lot of screws to come out just to get it apart. Okay, what else is that? That's now free. What's next? This should come off now. If it doesn't, just use brute force. What is holding this? There's a tab on here. There's got to be another screw in here somewhere that I don't see. Oh, yes, under a plastic cover. Well, that would explain why. Just put the good old hidden screw in here just to frustrate the person taking it apart. It'd be interesting to see what a new laser printer is like inside compared to these old ones. It's guaranteed they're not going to be built anywhere near the standards. Okay, this is the optical engine. This is what we want to see. And let's get this. I think that's the optical engine. Pretty sure it is. Remove a couple screws and this whole block should pop out. And we can see what's inside it. So this should remove this entire laser block, and I say it'll be interesting to see whether it's a single laser that's using a mirror to multiplex to all four drum, or if it's using four separate lasers. So we'll find out in a minute as soon as I figure out how to pull this thing out of here. It should just lift out, I think. Maybe some more screws in the bottom. Probably are. Looks like there's another screw down here in the bottom that I need to take out. One missing from there already. Okay, that should allow this to lift out. Which it does. We'll just unplug it there. Alright, this is the laser assembly. Let's pop this sucker open and see what's in it. What do you think? Gotta check out that scanner, that's for sure. Is it a shutter? Oh, I think it even has a shutter. Yeah, I think it has a shutter here that covers the laser when you open it. They thought of everything. Okay, does that lift the cover off? Oh, there it is. Cool. That's exactly what it is. There's a shutter here that blocks the laser. So here's how the scanner on this one operates. The laser is over here. It's an infrared laser. There's a shutter on it. Is there just one? I see other lenses over here. That's why I'm looking to see. I see two lenses here. I guess the laser comes out over here. There are four lasers. If we look down here, yeah, there's four lasers on here. I thought maybe at first it was just a single laser, but there's actually four. You can see the laser lenses down here under these shutters, which close when the door is open. There's four lasers. The lasers shine in through these separate lenses here, which hit the two scanners. And as the laser beam is hitting the scanners, one beam would be hitting this scanner, which would be reflecting the beam through this lens and then into this mirror. The other beam, as this rotates, it will scan from one side to the next, and then the next line, and so forth and so forth. And then the other laser is firing up here. They've got a, I guess this is what this is. This is to block. I'm going to guess that's to block the beam from refracting around. The second laser shines through. Its path is through here, and it hits this side. So as the scanner is rotating. See, it's when these spun up, this is when we heard like one hell of a screeching sound. It sounded like the bearings were shot in here as it spun up. Anyway, looks like, yeah, the 4 lasers shine here for the 4 colors. I can lift that out. Now you can see the lasers. 4 laser diodes, 1, 2, 3, and 4 for the 4 colors. They shine through these lenses. The lenses then go through another lens. This will be probably a collimator lens here. And then it hits the scanner, which is a 4-sided mirror, very reflective, as you can see. And that scans one beam this direction, so it scans across like that, and the other beam would scan the same way when it hits this mirror here. The laser would hit the mirror there, and as the mirror rotates around, the angle changes so that it scans around this way, like this. And the same for the 2 on the top. One laser here hitting this mirror, so it would start right when it hits it right there at the angle, right across here, and it would reflect through the lens. And then as it rotates around, it scans the beam across this lens, and the same with this other one. Laser shines out here. This is to keep reflections down, stop the beam from shining off and reflecting around and causing interference. So you get the 2 collimator mirrors that are spinning. They're called collimator mirrors. These are spinning, the lasers are pulsing, and then the laser shines through, goes through, it hits this mirror back here, this red mirror, and then it's reflected out through this lens and into its appropriate drum. Quite the elaborate system. And that way it can scan all 4 colors at the same time using 4 lasers. Whereas my older, well, I think this is probably about the same age, but my Samsung, it uses a single laser and does the 4 colors independently. So do black, and then cyan, yellow, and magenta. Does the 4 colors separately, and then combines the 3 of them together on the transfer belt. So it results in significantly lower output. I think it was 6 pages per minute when it's in color mode, but in black and white mode it's like 24 pages per minute. It's fast. Like, it's really fast when I'm printing just text. But the color was slower. But again, no problem. It was fairly inexpensive to run that printer. We'll pull these boards out here and get a look at the lasers themselves. And there's the lasers. 2 little laser diodes right there. Infrared laser, obviously. And this other one is probably I'm going to think this is probably a detector of some type. It was facing into this cavity here as well. So what that's picking up is maybe feedback. Oh, I guess it must be, because it's also looking into here, and it's looking through this lens, or it's being used for synchronizing. But there would be a pulse coming back from here as well. So the lasers are shining out through here, same as on this side, and then there's going to be a reflection that comes back. There's a 3rd lens on here. You can see the 2 lenses up front there. You can see them. There's 2 lenses here, and there's a 3rd lens there that's at an angle, which is obviously going to be picking up a reflection back. It's either going to be used for timing, or it's going to be used for, more likely for timing. You know, there's a pickup on here. I bet you it's picking this up. That's what it's doing. It's picking up a reflection. There's a portion down here on the mirror, or on the motor, if you see down here. I bet you that's what this is looking at. As it spins, laser light is also reflected off of this right here. And that is reflected back through this optical pickup, or this lens, and picked up by this pickup. And that would be used for synchronizing, so that the printer knows the position, where the starting position is. That's what that's going to be. On the back side of the board here, we're going to have the laser driver ICs, and this other one here is probably the pickup. Looking at the way it's wired, this is going to be the preamp for this optical pickup, which is going to be used to synchronize. These two here are driving the actual laser diode itself, and you're going to have power control settings for each laser. And again, the corresponding ones on this other board here, these are the same boards. RM1 2010 is the part number for that. But this here would have been sold as an entire replacement part. Obviously, if you pull this thing apart, you're never going to get the alignment back. This was almost glued in place when I popped it off. But these are not designed to come apart. These are designed to be replaced as an optical unit. These were actually glued in. You can see the glue that was on there to hold the lasers in place, because obviously the alignment is most critical, and if the alignment gets out, then you're going to have a problem. This is also if this gets dirty, right? If you get toner inside here, this is why this is a sealed unit. This is sealed on the front here. There's a sealing point here. But this is why there's also a sealed unit to keep dirt and dust and toner out of the optical pickup, because once it gets contaminated, it's going to give you foggy prints. And again, the same can be said for putting your grubby fingers onto the mirror surface. That's going to result in really bad quality prints. That's why we're gonna do that, just to mess it up. Let's pull out one of these motors. We can take a closer look at this. Since this is a full teardown, I might as well tear it completely down. Here's some of these horrid capacitors, right? Another ticking time bomb. I don't know if these are from the era of when they were bad or whether these ones are okay. This is probably not a problem on this, because this would have been a little more vintage than, a little more modern vintage, I should say, than all of the bad cameras, for example. We'll take out this little guide here as well. Lift out the motor. Another precision part, of course. Little motor drive IC and filter cap, and here is the mirror itself. It spins and scans the laser, complete with the synchronizing. Looks like that's just a black piece, so I guess how it works is the pickup detects incidental laser radiation that's hitting this, and as this rotates, the black section, I thought it was silver at first, but it actually appears to be black. So as it spins, blocks the laser light right on that corner right there of that mirror, so that it knows this is the end of its travel and that the next one's already begun. Anyway, that's what that would be for. Interesting to see if I can spin this thing up and make it run. Oh well. That's that. Now I can put this thing back together knowing what's in it. I'm waiting for someone to make the comment, because I know that they will. Well, why don't you keep the lasers? You should keep the lasers. And my response to that is, why? It's not like they're going to be useful for anything. It's not like you can see the output. They're an infrared laser, so it's not like you're, it's not like the laser could be really useful for anything other than a laser printer, wherever the hell this thing went on. That went in like that, I know that. Not that it really, but went over here like that. Okay, not that it matters, but yeah, there's no point in keeping any of the parts from the actual laser scanner. It's not useful for anything other than the fact that we disassembled it to look at it. But as far as useful parts, there's nothing on here that's of any use or any value to me or probably anybody else, because again, it's infrared. You're not seeing it. All you're going to do if you play around with a laser like this is risk damaging your eyes. That's the way I look at infrared lasers. They are, I think, far more dangerous than visible lasers, because, for example, the laser in the DVD player, like the one in front of me here, which is just getting ready to recycle and go back to the beginning here, it's at the end of the disc. But a red laser, if you shine a red laser like a laser pointer in your eye, you're going to look away. There we go. It's gone back to the beginning again. It starts to disc over. You're going to look away from it because you can see it. And if it's bright, like if it's a green laser or a red laser, you're not going to stare at it because you can see it. And the natural reaction to a bright light, like looking at the sun, is to look away. So you're not going to look at a visible laser. An infrared laser, on the other hand, you can't see. And because you can't see it, it makes them far more dangerous because there's no instinct to look away because it's not in the visible spectrum. You can't see anything, so you could be doing damage to your retina without even knowing it. And that's what makes infrared lasers far more dangerous to deal with than visible laser. The last piece on here that we haven't looked at yet is the transfer belt, which is this is going to be a messy one to take this thing apart. It's got all this bloody toner on it, but we will take this apart in the name of science. We will rip this thing apart and take a look at what's inside here, which is nothing really. It's going to have some wires that are used, that are connected along the edge here to the high voltage generator, and that is what draws the toner from the drum over to the transfer belt itself. We'll take apart a toner cartridge too. Yeah, they do. It's good. There'll be a corona wire here. There'll be a contact on the side. This is where high voltage would get stuck into the cartridge itself. I'm pretty sure on the other side, over on this side, there'll be a contact, I'm sure, for the drum itself. Or is it on this side? No, it's on this side. There'll be another one on here, which there is down here. There's a terminal right here. That's where the high voltage gets put into. So there'll be a corona wire in here as well. Well, we'll do the drum and then we'll rip apart a cartridge to see what's inside. I'll do the black cartridge. The other cartridges aren't dead, but they're not going to get sold or anything. I'm just going to recycle them. But the black one is the one that says it's empty, so it'd be the least messy to take it apart. This is another way that the guys at the printer shop told me this thing was shot, was because of just the way it distributed all this toner right onto the page, onto the transfer belt. So we'll just try to clean off this as best we can. Losing a battle here, fighting a losing battle. Holy crap! This thing had a lot of toner all over it. What a mess. This is a electrically conductive belt, right? Oh, there's a tear in it too, like that. See, that was shot. There's a tear in the belt. To hell with it. Let's just get rid of the belt. What do we need this for, right? Can't see what it built like if the toner of the transfer belt's there. So that's the transfer belt. It's made out of carbon. Had a tear in it anyway, but these are the rollers that press the transfer belt up against the drum, each respective drum. As the belt is turning, there's a roller here that presses the transfer belt up against the drum, and these would be electrically conductive. They say don't plug it in, take it apart. You know how the saying goes? Well, that's what we're doing. It's the back cover. I remember the old photocopier that we had at work. It actually had a thin, like a strong tungsten wire. You could pluck it like a guitar string and it would ting. And it used to make a tinging sound once in a while. This one here looks like it's just got metal strips that go across the unit. Where is the contact here? Here's one here. Which one is it? Are they making continuity somewhere? Yeah, I believe they're actually underneath these rollers. Let's just pop the rollers out. I'm pretty sure this is probably conductive. In fact, I'm guarantee it's conductive foam. bet you it's right in here, the connection. Ah, there's where it is. Okay, these are actually connected on the end here. There's an electrode. You can see it right there. If I pop that out, there's an electrode in here, and it makes a connection when this gets pushed down. Right? Release it and it disconnects it. Push it down and it connects it. There's the connection. Now we know that's how these are connected. That's why when I was trying to test it, I got nothing. Here, it's not until you push it down, and then this becomes conductive. So this is the actual corona here, or we're not using a corona wire. This is the high voltage transfer. High voltage goes in through these terminals. There is a connection right here. If I pop this apart, you'll see it. There's a spring underneath here that connects this shaft for the roller. Right, the roller would have been sitting in here like this. Goes like that. And when it's pushed down, so when it's disconnected, when you open it up, it actually breaks the connection. Even though these are disconnected from there, it actually breaks the connection here. And when you close it up and these get pushed down, the connection gets made between the 4 rollers and the 4 contacts to deliver high voltage to the back side, or to the shaft that runs down the middle here, and produces an electrostatic field on these. They're carbonized type rollers, which then draws the toner from the cartridge, from the drum, onto the transfer belt. And the transfer belt itself is also conductive slightly. Right, this will be conductive type material, carbon in here, so that the electrostatic charge gets pulled through, so that as this passes over the drum, it picks the image up. Learned anything yet? Alright, I'm going to now throw this thing kind of, I'm not going to put it all together obviously. I'm just going to put a couple screws in to kind of hold this thing somehow in a somewhat reasonable facsimile that shows that it's assembled, so that I can get rid of it, because obviously the recycling place is not going to want to take it in a bunch of pieces. So I'll reassemble a bit of this, and then we'll take apart a cartridge. That little sensor that was on the back there, that's probably an ozone sensor, because these machines do produce ozone when they're operating. And if they produce too much ozone, they have to have a way of detecting that they're producing excessive ozone and shut down, and that's likely what that little sensor is here, HSU07. That's probably an ozone sensor. Doesn't say anything on here, but I'm guessing. I'm going to go on a limb and say that's an ozone detector. Again, I'm not going to put this thing all completely back together. I'm just trying to mount it reasonably so that put enough of it together that I can put the top cover on it, and then I can get rid of it. I just don't want to hand the thing in all kinds of pieces, so I'm just kind of sticking enough of it together that I can put the cabinet together and then get rid of it. So now we're going to look at the cartridge. And no, I'm not going to take the cartridge all apart. I don't want to get toner everywhere. We're just going to briefly look at the cartridge from the outside here, because I don't need to have black toner all over the place. And even though it is probably pretty close to being empty, this one here shows as being empty. I wonder if I shine my flashlight down here whether we'll see anything come back. See, there's a reservoir tank, and then there's this collection tank. Yeah, I can see right through there too. So these printers use a chip in the back here that is used to count the number of copies that they make. And well, that was what remained of the chip. I just blew the chip apart. I just popped it out and popped the top off of it. But there is a chip. There was a chip in here. I pried it out. I broke it. But there was a chip right there that is connected to the two contacts on the other side. And basically what would happen is they would apply a voltage to the contacts, and that would power up the chip, and the chip could be written to or read from the printer. So every time a print was made, it would tell it to add another print to it, and it would respond. It's a little memory chip, and it would respond to the printer, telling the printer how many copies has been made. And once you got to the maximum number of copies, and you can see there's the remainder of the chip there, they basically glued it down so that you can't remove it. But it was a little blob of epoxy on the where we are here. Where are we? Anyway, this is the remains of the chip itself. Just a little blob of epoxy that was glued over top of the actual silicon itself. That's to stop people from reading it. People came out with aftermarket chips that you could actually reset. But the problem was they violated the Digital Millennium Copyright Act. So the companies that made these aftermarket chips had to stop making them because, well, the Digital Millennium Copyright Act, that is IP, intellectual property, that's stored on that chip. And they went to court in the States, and the courts upheld that the printer companies have a right to prevent people from making counterfeit copies and counterfeit cartridges. And what companies did was they reverse engineered the code, and they came out with their own chips that could be reset. What the printer companies did was they updated the firmware on the printer so that if you used reman cartridges and they didn't have the OEM chip, they wouldn't work. And there's a big, at the printer shop that I went to, there's a big sign that says, if you're using reman cartridges, do not update the firmware. Well, the reason for that is because they figured out a way to stop them from working. Let's see here. No shaking, no sunlight, and no temperatures over 35 Celsius. And it says to rotate it like this way, like 5 or 6 times when you get it. Anyway, in here, there's a little lever that lifts up the door that covers up. And this is what happens. You can tell this one's shot because of this, just the toner that's on here, but product of Japan, you see. As the printer is printing, there's another corona wire which will be right in the bottom here. And what happens is, as this is rotating, it's going to rotate counterclockwise, I guess, this way. It's going to rotate down top to bottom. If I can turn it. It's going to rotate that direction because that's what way the belt is turning. The belt is going down top and then it comes up with the paper on the back side of it. So as the drum rotates, it first passes over this corona wire over on this side, which puts a high voltage charge, which puts an electrostatic charge onto the surface of the drum. This drum here is photoconductive. I just ruined it. It's already ruined. But this is photoconductive. So it puts an electrostatic charge onto the drum. Then the laser comes along, and the laser scanning going in through the back side here, it scans the charge. It scans the drum itself, and it changes the resistance of this green material. This is a photoresistor. It changes the resistance of it, which discharges that electrostatic charge that's been placed on the surface, because when it's dark, it's a very, very high resistance. So it takes on static electricity, just like if you walk across the carpet and pick up static electricity on your body and then touch a doorknob, you get a shock. Well, in this case, it's putting that electrostatic charge. It's like taking a balloon and rubbing it in your hair. You're putting electrostatic charge on the rubber of the balloon, and then it will stick to something because electrostatic charge will attract. Just like the old tube TVs, right? You always had to dust them off because the electrostatic charge on the surface of the picture tube would attract all the dust. And that's exactly what happens with the toner. So once you've discharged by the laser scanning one line at a time, as this is turning, the laser is scanning. And as it's turning, the laser is discharging. Wherever the laser hits, it's going to discharge the surface. But when you want to put a point of toner, you shut the laser off, so that you're creating, and I can actually draw this on here, you're creating a, as the line goes across here, and you're doing this line by line, dot by dot. So now you've created an image by discharging the electrostatic charge wherever the laser hit, and wherever the laser didn't hit, you're leaving that charge there. The drum, as it rotates, then passes by the toner reserve, which is also turning on a roller up top. Wherever there's a static charge remaining, the toner gets attracted to that remaining static charge, and then as the drum continues to rotate, that image is now coming around the front here, and you could actually see the image on the drum if you're able to see it. This presses up against the transfer belt, which has another electrostatic charge on it, a stronger electronic charge of the opposite polarity, and as I say, opposites attract. So one would have a positive charge, the other one's got a negative charge. So that negative charge that's on the transfer belt, or the rollers behind the transfer belt, then pulls the image off of here, and it transfers on to the transfer belt to be transferred onto the paper. In a monochrome laser printer, there would not be a transfer belt. This would press right up directly against the paper itself, or perhaps an intermediate roller first, but generally the paper goes right up against the drum itself, and the toner is then deposited onto the paper, and then goes through the fuser. But as we saw when I took it apart, the fuser itself is actually in pretty bad shape too on this unit. It had all kinds of toner that was stuck to it, so that fuser itself was also toast. On the bottom here, there's some plugs. This is where they plug these up. Normally what people do when they refill the cartridges is they drill a couple holes into the bottom so they can empty out the collection, because of course any toner that doesn't get used, that doesn't get transferred, and there's always going to be a latent image, right? Most of it's going to get transferred, but there's going to be a slight latent image that remains on here, and then as this turns, it's scrubbed off and it's deposited into the waste toner container on the back side. So the toner, the fresh toner is up on the top here, and the waste toner is on the bottom. So when you refill these cartridges, when you could refill them, you would punch a hole in the top side so you could fill up the toner reserve, and the bottom side here, this is where the waste went. On my Samsung printer, it used a separate waste tank, and it collects the toner and puts it into the waste tank itself. Anyway, I think that's probably about all I can show you on this thing. I don't think there's much else to show you on here. As you can see here, there are rollers in here, so forth, that turn. When this turns, there are rollers that turn inside as well. I guess it drives here and it drives the front. And there's also an electrical connection there. That's to provide the capacitance so that it keeps the drum at ground potential so that they can give it a static charge onto the surface. And when the laser hits it, it discharges to ground and dissipates the charge through that little copper electrode there. I think that's probably about all I can show you guys on this. I don't want to take this apart because I don't want toner all over the place, but this gives you an idea of how these work. I wonder if I can open this up just so we can see some of the guts of this. If I can pop this piece open, maybe we can break this open and see inside here where the laser shines down. We might be able to see the corona wire in here, because this should have a corona wire in here to charge this up. Can we see it? Try to open this up. Try to open this up without creating a mess. How does that sound? Don't let it go any more than that. That's the toner in here, in the tank. We can see the wire in there or not. Maybe not. Anyway, it's in there. But I'm not gonna go any further than this. I don't want toner everywhere. All right, I'm going to end it now. Thanks for watching. We'll catch you in the next one. Bye.